Welcome. So previous class I have stopped somewhere here. That is the living groups and nucleophile both has to be present axial position and they has to be adjacent to each other. Then only that will occur through Ngp. Otherwise that will not occur through Ngp. Okay. So the condition, this condition is very important. So what I says that living groups and that nucleophile both has to be present axial positions and they has to be adjacent to each other. Then only that will occur through Ngp. Otherwise that will simply happen the SN2 reaction. So what we have seen in these questions that I was discussing in the previously. So what I says that in this case, so both has to be at axial position. Now we see that this is not in the axial, okay, and this is at the axial position. So both has to be occur, then only that will occur through Ngp. So it will not occur through Ngp. So no Ngp. Okay, so in case of pinnacle rearrangement or semi-pinnacle rearrangement, if the living groups and nucleophile both are not at axial position, then also that will pinnacle rearrangement will occur, that this will use to migrate. But for the case of Ngp, this and means living groups and nucleophile both has to be axial and they has to be adjacent to each other, then only that will occur through Ngp. Okay, so here both are not in the axial. This is there at the equatorials and this is at the axial, so this will not occur through the Ngp. So what happened here, simply SN2 reactions will happen. So here what will happen, simply the SN2 reactions will happen, means that in the solvents we have this ACO, so this will attack, and this attack always axial attack is preferred. So always try to attack that axially, okay, that is always preferred. So if is OTC in the different directions, first make that into such a way so that axial attack is possible. So now this will attack at the axial positions, okay, and it will going to leave it. So what will get that OAC, and here again we will get that OAC. Okay, so what the product will be, so this will not happen through Ngp and it is happened simply through SN2 reactions. So what will get, that inversion product will get. So this is going to be what, this is the reactants and product is, you see here. So this OAC is above side, so I can put it in like this OAC, and this OAC is the downside, so this is going to be right side. This one we can put here, or also we can put here. Okay, so what we have seen, that one is at the above. So you see that wherever that OTS leave, that OS is attack back side of it. Okay, so this is going to be a inversion product you will get, inversion product, and it is happened through the SN2 reaction. This SO2 is the from solvent. Okay, so here it will happen through SN2 reaction, not by Ngp. If Ngp will happen, then retention product we used to get. Okay, now moving to the next questions. Now if we ask the compare of the rate of the solvolysis, so wherever Ngp will happen, that is going to give a fast reactions. So we see here in these examples, okay, in these examples what is in that this lone pair is there. So here this is the single bond through rotations is possible, so we can make this one, this and this. So I can do the rotations because single bond through rotations is possible. So I will make this, here I will have that Br, here I will have that H, and here I will have that CS3, and here I will have that CO and OPH. Okay, so now what will happen, that this lone pair, this is the antibody will be in this side, so this is going to attack here and this is going to hit now. So this the single bond through rotations is happened here, single bond rotations. So after rotations we get here, and to this antibody this lone pair will attack and this living group will leave. So here what will happen in that Ngp is happen here, because Ngp means that the nucleophile near to the reaction center that will attack. So here how many member ring will form, so 1 2 3 4 5, so 5 member ring will form. Okay, because this 1 2 3 4 and 5. So 5 member transition state will form, not 5 member. 5 member transition state will form means what it will form here, that is going to be like this, and here we have that CO, here we have that OPH, and here we have that carbons here, and this is going to form here, and here we have that H, and here we have that CS3. Okay, so this 5 member transition state has formed 1, 2, 3, 4 and 5. Now that whatever the solvent is there, that will attack. So solvent is, let's say, SCO, so this is going to attack this, so that means that it will attack to here, or okay, so this will attack to this one, then this is going to yes, so this is going to attack to this, the where the living group live, that side it will attack, so it will attack here. Then what will get, that we will get this one, COOPH. So this will attack, then this is going to leave here. So what we get here, carbon, here we will get that OSC, here we will get that H, and here we will have the CH3. So this is the final product. So this will happen the very fast reactions. Reason is that this is happening through Ngp. Okay, but in this case this has to attack, but here how many members ring it will form? Look, that 1, 2, 3, 4, 5, 6 and 7. So 7 member transition state is not stable, so this will not occur through Ngp. So it will occur simply that ACO will attack here. Okay, that is directly attack here, that means simply SN2 reactions will happen, because here that 7 member ring will form, and that 7 member ring is not stable, so that 7 member cyclic transition state is not stable, so that will not form. So here the rate of solubilization will be A is greater than B. Okay, that's how we check here. Now in this case 2, here what will happen, that both has to be, if it is a cyclic transition state, then both has to be axial, then only that Ngp will occur. So here no Ngp, here Ngp will occur, so B is greater than A. Okay, now moving to these examples. Yes, so whenever that acid is there, then acid work is to donate that H plus. Okay, and this living group, this lone pair will attack here, then what will get, we will get this one, this is I, and this is going to be the OH2 positive charge, so this is become a living groups. Okay, now what will happen, convert this into the chair form. Okay, one I is in this sides and another is the down, so that I can make here OH2 positive, so this both are in the axial, so this can happen through axial. So what will get, that this is attacked from that above sides. Okay, so OH is in the which sides, OH, okay, I is above side, so I will attack here, so this is going to fall. So what it will fall, and this have that, means this is attacked by like this, so this is going to be get that this form. Okay, so that going to be the I, and okay, okay, so this is a 3 member cyclic transition state will form. After that what will happen, so this is the 3 member cyclic transition state will form. After that what will happen, Cl minus is in the nucleophile, so that is going to attack axial, so axial attack will occur, so it will attack here. It means what will get now, so here we have that chlorine and here we have that iodine, that means this is going to give this product. iodine, and here we have that chlorine. So this is the final product. Okay, so that's what here you get. Which one? This one. Okay, here we will get that iodines, and here we will have that seal. So this is the final product. Now in this case, if base is there, then base is to abstract the proton. So this will abstract this proton. So what will get here? This is the iodine here, and this is going to be that O minus. And now this here we have this dipping groups. So it means that what it will forms here, it will convert into that forms. Okay, so let's make iodine is here and O minus is here. So this is below attack will happen, and this is going to leave here because this is a dipping group. So this is going to forms. So below attack, so here oxygen is there, and oxygen is in the downside, and that will attack to iodine. So from the below side it will attack. It means iodines. This is the going to be the product for this case. Okay, so this is the about of that where axial attack will happen. This is about of if HCl is there, what is the product, and if base is there, what is the products. Okay, now where that Ngp will occur, that rate is the high. Okay, so now we are moving to that next, that is the regarding of the transition state. So what happened that in Ngp, okay, always cyclic transition state will form. For both cyclic, non-cyclic, or aromatic rings. So for all the molecules, that transition state will be always cyclic transition state will forms. It means that whenever you are doing this type of PHS, here Cl is there, so this is going to form a cyclic transition state. Okay, it means 1, 2, and 3. So this is S, here pH, this is positive, this cyclic transition state will forms. Now the question is that here we form the 3-member ring. Okay, so which member ring is most stable? So whenever we forming that this cyclic transition state, that is we will see this cyclic transition states, that we can see that by using two terms. First term is two terms. So first term will be the enthalpy, or you can say first term we say that entropy, and second term is enthalpy. So by these two terms we will decide that which transition state is stable. Okay, so whether that is 4 and 5 and 6. So by looking on that entropy, what we seen that 3 and 4 member rings ring most favorable. The reason is that what we say, let's say we have this ring, let's say we have that SPH, and here we have that chlorine. So here what will happen that how many number of atoms are easily moves? So this one 1, 2, 3. So this is not easily movable, means 1 and 3 they are 1, 3 means I can say that this one and this one easily move. And whenever you make this into a cyclic rings, means S, and we will have this positive pH. Now what will happen that here that randomness is how much? That 1 2 3. So here single bond through rotations is possible. So 3 members means 3 1 2 3 3 can easily rotate. Okay, here randomness is high, increase because 3 member easily rotate, but in this case that randomness is decreases, randomness decreases. Okay, but now if you move to that, let's say I talk about of that PHS, this is 1 2 3 and this is 4. If we have this CL, in this case how many? That randomness is we look here, in this case randomness is increases, and here that 4 molecules easily rotate because single bond through, reason is that single bond rotation possible, rotation possible. Okay, so here 4 member easily, 4 molecules easily rotate. Okay, reason is the single bond through rotation, but if we form that, then what we get is pH, this will form. Okay, here again that randomness is decreases, means here 4 2 it going to form that 1. Okay, here what we get, that 3 2 it will form the 1, here 3 2 1, here what we have, that 4 2 1. Okay, so similarly if you have that 5 member rings SPH 1 2 3 4 5 Cl, so here what you have, that SPH positive 5, so 5 to 1. So the randomness decrease, where here the randomness decrease is very high, 5. And similarly for 6 member that is 6 to 1. So you see that here decrease is 5 decreases, here 4 decreases, here we have decreases 3, and here we have decreases 3 to 2. So where the randomness decrease is very less, 3 member rings. So that's why you see that. And we know that for delta G, this means that delta H minus D delta S, it means that here delta S should be, for delta H to negative delta S has to be positive. It means that S should be increases. It means that where S is high, so 3 and 4 S is high because here less decreases. Okay, so 3 and 4 S is high compared to 5 and 6. Okay, so in terms of entropy, what I said, that 3 and 4 S is high, but or you can write high. Then so in terms of entropy you can say first 3, then 4, then 5, then 6, then 7, then 8. Now in terms of enthalpy, what the enthalpy case, 6, 5 and 6, that I can write that 6 and 5 is higher than 3 and 4. So combining the factors, combining the two factors, that is entropy and enthalpy, what we see, that 5 is most stable, then 3, then we have 6, then we have that 4. Okay, So this is the combining factors for stable cyclic transition state. Transition state for Ngp. It means that wherever we see that 5-member rings, then that Ngp will quickly happen. Then 3, then 6, then 4. After that we get that 7 and 8. Okay, so this is the very rare cases. So that's why I told that while discussing this one, here that will not occur through Ngp. Reason is that how many rings it will forms. If it will do that 1, 2, 3, 4, 5, 6, 7. So 7-member ring is not stable cyclic transition state. That's why it will not occur through Ngp. So that cyclic transition state should be either 3. So this is the combining that either 5, then 3, then 6, then 4. Then in this case only that Ngp occur. Okay, and that the results, some experiment results is there. That is that if you look that for the case of 3-member rings, okay, 3 members, this is a 4-member rings, that reactive rate is 1. Okay, if it is 4-member ring, and if it is 3-member rings, then the reaction rate is nearly 2000. And if it is 5-member ring, you see that very high, that is 5000. So very stable, means that is fast reactions will occur if it is 5-member rings. Then if it is 6, then that is 20. You see how much. And 7 and 8 are very rare, means not occur. We can say that no Ngp occur if cyclic transition state is 7 and 8. Okay, so today up to this, we'll discuss more in the next class. Thank you.